Okay, so my name is Munro. I'm a technical consultant for Cancel. Today I kind of wanted to just quickly talk about scanning to a Revit environment. I get a lot of questions in regards to this, so I thought I'd put it into a nice, neat video. So I wanted to take a look at a specific project. So in this case, the specific project is this older heritage building, and this is a building located in Edmonton, Alberta, and the architect wanted to do a renovation of this building, and they wanted to capture all the exterior since it was a heritage building, and they wanted to create a Revit model, a 300 level model. So this is the project location shown in Google Maps. And what we did is we deployed people in our team to go out there and scan and capture the data. And we ended up with a really good data set. So we're going to take a look at that one. Okay, so let's just move forward here. At Cancel, we actually have several different workflows, but we're just going to focus on this workflow from a scanning to a Revit as-built model. This is the actual workflow that we utilize, and typically we look at the data that's coming from the scanner, which is here, and we build a registered point cloud from that data. So this is kind of where we're at for this project in regards to data that we're starting with and how this workflow is coming through. And this is going to utilize some tools to extract data in a more reasonable format. Okay, so just to give you an example, with Revit previously, if you're not using any of these data extraction tools, a lot of what you're doing is tracing. Okay, so I've loaded in a point cloud into Revit just to show you as an example, and if we start scanning in and looking at it, the point cloud is fairly sparse. There's lots of data here. It's good as it gets, but this is kind of the technology, right? So you can see lines here. It's pretty tight in this regard, but if you're trying to pick specific points, it becomes a bit of a guessing game. And so for me, the power of point clouds comes in the amalgamation of the points, or at least groups of points. So what we end up doing here is, in the older style, we would create a wall in Revit, and we would snap to some of these points to try and figure out where we are, right? So you can see that it's snapping to individual points, but is this the wall? Is this an artifact? Is this noise? We don't know. So we would essentially start, making our way around this model, trying to build off the facade of the wall. So it becomes a really hard situation where you're trying to be as accurate as possible. So typically what we would have done is we would take this wall and we would go to the outside, and we would essentially come here, and we would make our way around this wall until we felt that we had something that was reasonable as far as the accuracy. So this is can be a bit of a time-consuming process, obviously, and you work your way all around the model, trying to be as accurate as possible, and trying to make sure that things are represents the as-built condition. So there's a couple things that are wrong with this, obviously, but also, we're not even taking into account the plumbness of this wall. Revit has a little couple of nuances that we have to work backwards from sometimes in regards to, it's a design tool, so it wants to make sure that everything is at right angles to each other and perpendicular and and vertical. So coming back to this workflow, just to point out a couple of things, some of the tools that we're going to use to extract these are tools called Edgewise, and it's created by a company called Clearedge, and Pointsense, which is created by Qubit. has recently been bought out by Faro. So what we end up doing is we use these tools specifically to automate and leverage algorithms to extract data. So they're averaging points. They're taking thousands and thousands of points and they're averaging them to become a specific value. So you get a really average value, which would give you the increase in accuracy. And then we would bring that rough model into Revit as Revit elements, and from there we would use Pointsense to extract some of the details. So Edgewise is really good at extracting elements such as walls, windows, ducting, piping to some extent, structural components, things like this that are like specific shapes. And so we want to use that because it's an automated and semi-automated process, and we want to use that where we can bring it into a Revit environment, but then also be able to use Pointsense to extract other information that isn't in those specific shapes that Edgewise picks out. And then from there we would have as-built that's a deliverable that we would continue with design and use it for drawings and analysis and everything. Okay, so we have this now located in Scene. So our team has gone through, scanned the project, brought it into a Scene environment, registered all the point clouds. Now, you can do this in Recap as well. However, I find Scene to be a little more powerful in that regards. So I prefer to work from Scene data, but I mean, there's no reason why you couldn't do this in Recap as well. So they overlap a little bit. So this data here, a couple of things that are really important. So typically people that are doing scanning are surveyors or from that realm of worlds, and they want everything to be as accurate as possible, including geo-referencing your building. Now again, this goes back to Revit being a design tool, and Revit wants things perfect all the time, and nothing in the real world is perfect. So we have to kind of make sure that our data set that we're working from is as perfect as we can get it in regards to how it will interact within Revit. So it is really important to remove as much data as possible. So in this case, we want to make sure we delete any points that we really don't need. I could really, since this is an exterior project, go through here and start deleting some of these points within the model and just getting out some of this interior data that we don't need, right? We're not doing an interior renovation, so we can just go through, clip out what we don't need, and all those data points won't be captured, and we can kind of clean up the model in that regard. So it'll just go through and delete those. Now, I didn't really want to come in here and show you much about Scene. It's a different conversation at that point, but I want you guys to understand that getting a really clean data set that's located properly is really, really important. Okay, so in this case, we have a data set. There we go. So it's all cleaned out in the middle. So we remove some of that data, which is great. It probably can go through and do a little bit more. But important thing to know that this is now set, these sidewalks are set to a 0 elevation, and when we look at these from different angles, we can see that everything is located according to how we need it located. So if we look at it front on, we can see that. If we look from the top down, it's located. So Revit's really gonna like this data coming in at those angles, and it saves you a step in Revit too of rotating all this stuff and getting it into the location. So clean up your model, or clean up your point clouds, excuse me. Clip out any of the data that you don't need, locate them properly, and then obviously you would like to go and save that data as a revision, and then also maybe to skip a step, when you bring point clouds into Revit, you have to index them, and you can do that with Recap, you can do it with Revit, but I find it's just really easy to do it out of Scene, And one of the things that I'll do is I'll select this and say I want to export as a project, and then from there, excuse me, I have to save this. So it's just saving a new revision, and that data will save. And what we can do from here is export this out directly as an RCP, so Revit Pointcloud project. Okay, so once it's done doing its save to a new revision, it will create this export as a project, and it automatically comes out as the format for Faro Scene, but you can change it over to a recap project and just export. So it'll just save you a step of indexing and doing all this stuff in recap. Now we're going to look at this portion here, is this Edgewise portion. It's a really handy tool to semi-automate and fully automate the extraction of some elements. Okay, so it's important to understand that this tool isn't going to get you a full-blown Revit 300 level model. It's going to get you a really good starting point to work from. So it's really important to understand that sometimes it's misunderstood that you're going to get a perfect Revit model at the end of this, and that's not necessarily the case. So from there, we'll extract some elements, and I'll take you through that process, and then we will bring it into a Revit environment. Okay, so here we are in Edgewise, Edgewise 5. I believe there's a newer version of this, not too much newer. Edgewise utilizes data a little bit differently. It's not necessarily a whole model or point cloud. It's more of components linked together to create this. So what we've done is that you have to come in here and you select your process and your scan. So what this is going to do is it's going to go through your data. So in this case, we've got to go to our scene data and our heritage building, our revisions, and we're going to go to the revision that I know is the most recent and select all these FLS. So now all these FLS files come from Scene that are all registered and clipped and located correctly, and from that you would open this. So this is kind of the heart and soul of Edgewise, and in this case we want to create a couple of different things, but just to kind of take you through some of the things it can do, we're going to create the points database, and there's some options that you can look at here, and we can look at that in more detail. And it creates this C3DB, so it's this database. The planar model is essentially, it's going to go through the model automatically and try and figure out what are planes. Those are key for the walls. We can optimize that data for Revit specifically, and if we don't, we can add more or less data depending on what we want to do. And they'll merge the planes. If you don't want individual ones, typically it'll create one plane file for every FLS file that you have, but you can get them to merge them separately or in different groups depending on how the algorithm sees fit to do that. So we can create a pipe model from this too, same situation, but we're not going to do that today. But it will also pick out ground surface models. There are much more powerful tools in this, but from an architectural landscaping standpoint, it is pretty handy. So we're just going to focus on these two things. Scans we're taking outdoors. Sometimes I find that this removes a lot of data that we could use as far as elevation benchmarks go. So I tend to leave that off. So you just say okay, and I'm not going to take you through the steps because I already have this stuff processed, but this process would probably take you around 45 minutes to an hour to process all the data correctly. It might be a little less than that, I can't remember off the top of my head. And once you have all that data processed, you have to assemble it in Edgewise essentially. So what we want to do is we want to come in and we want to grab first and foremost the database of the point cloud. So in this case, we're going to go back to the data that we were working with that was spit out of, Edgewise. And you can see here is that database that we were talking about. So we open this database, all files loaded successfully. And here is the database of the points that we're going to utilize. So we've seen this in scene. From here now we want to assemble elements, the extracted plane files that we had. So we go back to File. We're going to merge, these extracted planes. And so if we had pipes or ground grading, it would be these other two options. Select that one, and there's all the planes that we extracted. So you would select all those, open, you would save it as the merged file. So this gives you like a building file, so to speak. Here. You hit save. And once those are all loaded successfully, you end up with these extracted plane files. So you can see it's captured a lot of information here. It's created planes for these major walls, including some of the windows as well. So the idea here now is that it has a starting point. It knows the exterior of the wall. So if you had data from inside and outside, it would know the interior and exterior wall. So you would be capturing and obtaining the thickness of the wall. So in this case, we only have the outside. So that will be the starting point. The wall will be created from this plane backwards. What we need to do next is tell Revit where these levels are. So this wall, where does it go from? These interior walls, where does it go from? So this is where data capture in the field is really, really important. There's some elements that need to be captured. So in this case, we had stuck a scanner out this window so we could capture this ledge here to get this level. So it is possible to extract levels out of this without actually getting the software to determine that it's a plane, but it becomes this process of picking individual points, which I try and avoid. At some point in Pointcloud, you won't be able to avoid it, but you try and minimize it to its extent. So all I would go in here and I would come through and start saying, okay, we want to start picking these levels. So Edgewise will highlight what they think are levels and go from there. So I'm going to say that this is the ground level, and obviously there's a bit of a slope to this, so we'll have to play with that later. And here's maybe the top of slab, and here's the edge of this wall, and top of the building. So there's lots of levels in here that you would want to pick, and I'm not going to go through and pick every single one, but if you look at your level editor, you have all these different levels that are in here, and so the first one we picked was grade, next one was slab, and so forth. You would go through and you'd label all those. So what happens if you wanted to get, the level of these windows? Well, if you don't have that data, you don't have understanding where that specific line is as far as the point cloud is, there is ways around that. So you can come in here. I'm going to turn off everything. I'm going to go look as good as possible with this data, so you can see the ledge kind of coming out here. And I can just go in and identify these points. So it gives me a Z of 13.282. And you can do that a couple of times. And if I'm doing this, typically what I do is I take about 3 or 4 points, add them together, and divide them by 3 or 4 to get the average, right? So if you wanted to, and you knew that it was 13.1, you could say, I'm going to go to the level editor, I'm going to add one, it's going to be at 13.1, and we're going to call this windowsill. Okay, so now when I turn my levels on, I will have a level at that windowsill. So it's not the best way to do it. So the best way to do it is to have that data captured in the field, and sometimes you have to place artificial targets for this stuff, right? So some people will place a flat surface, bent metal, anything outside of that, so they can extract a surface off of it, so they don't have to rely on trying to pick points. So that works pretty well. Once you've done that, the whole thing kind of looks like this. Oh, before I jump ahead here, I just wanted to mention a couple things. Talk about adding these artificial surfaces in there, getting on the roof of these and getting up high to capture not just the walls in this case, but these elevations is extremely important. So once we've gone through and we've created all these levels that we want, and all these levels that we've created in here will show up as Revit levels in Revit. But once we're happy with our elevations and everything, we simply just say find walls, and it'll go through the whole thing and finds all the walls that it determines from the planes. So I'm just going to turn off the observed surfaces, the levels we don't need to see, and we can see the walls. And here we go. And so what I end up doing is we end up turning the point cloud on to some extent, and we can start modifying these walls. So if we know that this is obviously a wall that is joined, there's some overlap, you can select that wall. Don't worry about the joins at this point, because Revit will take care of them. You can see that these overlap, but it'll just join them as one individual wall, but I like to kind of clean them up so we don't confuse Revit. And you can see that some of these interior walls came through that we're not really overly concerned about. So at this point we can just delete these. If, just for example, if you knew that this went all the way to the basement, or to the main floor I should say, you can edit those levels to go from so the ceiling would be the top one, so let's say level 3, and the bottom one would be slab, and say okay, and then your wall would go to that direction. So there's a little bit of cleanup that is done in here that you need to do, and you can go through your entire model to clean those up and join these things. So there's several instances where this stuff needs to be kind of looked at. And obviously it doesn't create holes or openings in the walls. It's up to you to do that in Revit, and that's something we will look at with tools like Cubit. Okay, and here's the end example. I've also gone through and captured these windows, and we can quickly take a look at that, but I just wanted to show you, if we turn off the levels and the observed surfaces, and this is the cleaned up model of all the walls that are going to be imported into a Revit environment. Okay, so just looking at the window situation here, this tool works well if you have standalone windows, but acts more as like a placeholder for those windows. So the nice thing about this is that it'll come in the location of the opening that it's determined in Revit, and we'll create a Revit window. You would probably do some tweaking to that window, which we'll talk about through Cubit and Pointsense in a little bit here. But basically, just to show you how that works, we essentially say we want to find objects. So in this case, it's a window. Right now, it's the only option. There used to be doors, but there was an issue with them, so they pulled them out of there. But the window, you'd select the plane that you want to look for. So in this case, we're trying to pick out this one. So we'd select that, and we would show you where that, it showed the software where it is. And then you just say, okay, and if it's a grid pattern, you would have a bunch of them. So it would extract multiple windows really quickly. So it goes through there, it's found this opening, and that becomes your window 14. Okay, so after we've done all that, we need to export this all out to Revit. So to export this out, we need to just do one quick simple step, but just to talk about some of this other stuff, you can export these things out as like a COE format, which AutoCAD can read, and it would bring in the observed surfaces and walls as lines, and as the model itself, so it would potentially come in as solid. But Edgewise is really kind of geared up for Revit in the building side, and there's an export to Revit button. So you just say export, and I just want you to note that it's a C3 RVT, so it's not exporting an RVT per se, and it creates this file here that you can use to import into Revit. Just as a side note too, that this whole thing, creating the planes and the windows and the walls and the elevations, probably took me an hour and a half, couple hours maybe, to do all that. So now we're in the Revit environment. I've just opened up an architectural template, and we need to do a couple of things. So one of the things that we need to do is we need to bring in the point cloud. So if we go into insert, and I'm going to bring this directly from the RCP that was created in Scene. So I select that one. It's important to bring this to origin to origin. So this is the main reason why we made sure that it was located correctly in Scene, so that when we brought it in here, all our elements would line up as we brought them in, and would stay that way for the entire project. There's a QA QC part where we check to make sure that, you know, some of the stuff is accurate, that it needs to be that way. So if you go and rotate this stuff afterwards, some of your elements aren't going to line up. So I take this RCP and I open it up, and I'll bring in my point cloud, and you can see my point cloud here. Okay, and now what happens is I will go to the Edgewise tab, and I want to open the model that I've extracted from Edgewise. So I'll select that and open model, and I will come into that project. And that stuff was placed in Edgewise, and here's that C3 RVT, and we open that up. And it's asking us what it wants to round the joins of the walls to. At what distance do they have to be before they will join them? So 1/16 of an inch is fine. And what it'll do, some of the joins and conflicts, Revit has problems trying to join some of this stuff, but you can go in afterwards and just clean up that information. So it gives us a report, tells me that it's created windows, it's called created walls, all this stuff, and it tells you what it is that's located in the log if you ever need to go back and look at it. So if I go into Revit here and I turn off the point cloud, I get actual Revit walls with window opening. So you can see that this is a wall that's created as an edgewise wall, but we can change it to whatever wall that we want. And we didn't have to do anything about it. These are all just standard Revit walls. So you can see how sometimes it had a little bit of problem joining. So you might have to do a little bit of cleanup of that. But it's also created windows that are Revit windows that we can edit those windows. So what I would do in this case in the heritage building is build the windows from Pointsense, and then use these as a placeholder and just swap out the new window that I did with the one that I created. And so we'll go through that step as well. So now that we have these components located in here, sometimes it's a good idea to add the database. So what's nice about this is that we're loading the same elements again, the same RVT, but this is just the points that were used to create the planes. So if you didn't want to have to load in, say you had a massive point cloud, you don't have to load in the entire point cloud. You can just use the points that was used to create it. So if we open that database, it links it to it. And a couple of things that allows us to do is to take a look at how accurate this wall is. So select the wall that you want to quantify or to check, and from there you can say I want to do a color distance. So these are the distance the actual points are from the wall that's created in Revit. Okay, so green is good, yellow is okay, and blue is starting to get a little inaccurate. So you can see here the reason why some of these things are blue is because of architectural elements that were listed underneath it, right? So let's see if we can find a wall that is inaccurate, and we'll shift it afterwards to see if we can get it to fit correctly. So this is a really good way to test. So this one, it doesn't seem to be, I mean, it doesn't really matter, it's essentially a fence, but for all case purposes, let's just take a look at seeing if we can get that to match up a little bit better. So in this case, come back into the Edgewise, we can refit the wall. So original is how it came in here, originally how it came in. So this is going to try and line it up as best as possible in a Revit environment. So 90 degrees to each other, you know, as horizontal as can be and as vertical as can be. If you come into here, the best fit will fit that to the point cloud as far as an X and a Y, but the Z will still be perfectly horizontal. And then you can change it to be as built, so that if the wall is out of plumb, it'll build the wall so it's out of plumb as well. So in this case, we'll just try this one, and we'll see what happens. So it'll try and refit the point cloud to that wall, clear those points, and then we reselect the wall and run that color distance again. And hopefully everything turns out green. So much better. It's not as blue as it was before. Obviously some of these slats and other things that it's picking up is not correct, but before it was fairly blue. So it's shifted the wall to be a little bit more accurate. So it's part of the QA QC process that you'll have to go through for each one of these walls that you create in here, but it gives you the options to understand how accurate your walls are in regards to the actual points that were used to create it. Okay, and from after we have all this data in here, it's really, this is our starting point. And so from this data, we would start modeling it. You know, we would go in here and we would start creating our sections and start creating our elevations and start building this as required. So now we're in Pointsense, which is a Revit product. And it ties in directly into Revit. So if anybody is familiar with Pointsense and VirtuServe, VirtuServe used to be a standalone product that would work between Revit and VirtuServe. So basically you would pick elements on the photograph or the photogrammetry, and then you would pull into the Revit environment. So they've improved that a little bit to the point where they have it now kind of integrated into the Revit world. So we're just going to utilize, I'm not going to show you all these tools, I'm just going to utilize some of the ones that we used for this project specifically, and feel free to venture out and use the other ones. So one thing that Revit uses here, which is really handy, is these things called ortho images. So ortho images are essentially an image where an algorithm has gone through to try and insert more points based on the averages of the other points, or the other points I should say. And those points are snappable, so you can click to them within the Revit model. So if you're going to use this mentality of working specifically off the points, this is by far the superior way to go. So you can see the point cloud that we have here. It's pretty good. Like, you can see the outlines of the sill and the walls, but if you really get in there, it can be quite, there's a lot of points that make up that, so it's not as clear as possible. So what we can do is we can use this tool called the Ortho Image, and we can use it in the project environment in Revit and the family environment in Revit. And so basically what you do is you select this image, and it wants to know if you want a prepared image. Do you want to replace this prepared image? So yes, of course. And what it's saying here is that do you want to create a new view in your tree with the image on it instead of copying over top of the image that the view that you already have. So I want to insert a new view, and I just click Start, and it processes, and it takes about 2 minutes to do. And so instead of sitting through that, I'll just cancel it. And basically, what happens afterwards, it goes through this and it starts to find all these nuances and fine tunes the point cloud to some extent. And what you end up with is something like this, where we can zoom in and the point cloud is much finer in detail now. So to give you an example, the width of this is now around, these are bricks obviously, under an inch, way under an inch. So it becomes a lot more accurate and utilizes a bit of an X-ray feature. So it'll calculate the points within the middle of that section, if that makes sense. So you can start to really see now the outlines of these windows, and it helps you model to that with a much greater accuracy. So what we're going to do is we're going to model one of these windows so it's exactly as per the point cloud and as close as we can get it. And then you can use this window over and over again for the other windows that you've created. So we'll take a look at that. So the first thing you want to do is you want to start creating some ortho images of this, right? So we can look at this building from the north, and we'll turn on some wireframes so it's a little more clear. But again, it doesn't look bad, but as you zoom in, it gets a lot more pixelated and becomes harder to read. So we can create an ortho image of elevations as well as sections. So we'll do that to create this window. And the way that we do that, first and foremost, is that we're going to segregate this window with the section box. And this section box we'll use. And we'll just clip it out so we don't have to deal with too many points, because we don't want to process all these points. I guess in theory you could do the whole elevation if you wanted to. But we're just going to focus on this one window. And we'll just come to there because there's some architectural features maybe we can pick up. And bring it up there. And then also in the depth as well. So let's bring this in. And we'll just check on that from the top. Make sure it looks all good. So the more you pull out of this, the faster the processing times is going to be when you come to these ortho images. And none of them are that long. If you start processing this whole wall, it would probably take you a while. But when we're talking about individual elements, it's pretty straightforward. Okay, so what we want to do is we want to look at the views. So in this case, we're going to look at this view on front on, and this is going to be our ortho image of the front. So we'll create an ortho image, and it basically asks you what the pixel size is going to be, and if you want this color filling mode or X-ray mode. So the X-ray mode is the one you saw on the floor plan, and it's very good for doing sections, but as far as elevations go, we want to use the color fill mode. And from that we can just hit start, and it'll go through and start generating an ortho image of this specific sectioned area that we've done. So it starts to fill in the areas of the point cloud to make a really fine, detailed image that we can work from with more accuracy. Okay, so we're done here. This took about a minute to render out, so to speak. And then once you're done, you save it as these other saves. So I've gone ahead and saved this one, and then I've done a plan view as well as the section view. and we'll use those to help us in with the actual point cloud we'll bring in with a family environment, and we'll build this window utilizing these different ortho images. So the first thing here that I do is you can see that this window is just a fixed pane of glass. It's just a standard out of the box piece of window. So what we want to do is get like a double hung that goes in here that is a little closer to the geometry that is the actual window. So we'll have to load one in, and we'll take a quick look at what maybe comes out of the box for Revit and what we want to load in there. And so we'll just scroll down to Windows, and we'll look in here to see what options we have. So there's two double hungs, one with the trim and one without, and I'll get the one out. So I'm going to open this one and load it into the project. So this is pretty close. It's not perfect by any means. If you look at this, you can see that the edge of the window is actually probably a little bit away from where the actual edge is, and that's just Edgewise going through and trying to figure out the best fit, but it's not the best solution. So we want to tighten this accuracy up for sure. So in this case, what we'll do is we'll just load this window in place, because we just want the area, the rough area. We're going to shift it around to make it work for us. So what we're going to do is we're going to select that window that we just loaded, the hung one, and we'll take something that's a little bit bigger. Sorry, that might be the wrong one. I'll just grab a little bit bigger yet. There we go. So again, it's not even close to the right shape, but it's the right size, I should say, but it's becoming the right shape. Okay, so from here, what we'll do then is we'll just take this window, and we're going to edit the type of it, and we're going to duplicate this, and we're going to call it window type 1, window type 2. I think I already have one in there. Say OK. OK. And what we want to do then is open this up in the family editor. And we're going to save this as a family, so we're not overwriting anything else, and we'll call this, we'll just call this window type 2. And we'll put it in the right location. So from here we'll have our own window that we can use, and that is window type 2, and we'll create new windows as we go through, but first we want to load in some of these elements. So here what we'll do is we'll take some of the ortho images that we've created, and you need to do this in a 2D environment. So what we're going to do is we're going to come into the elevations, go to the exterior side, and we're going to insert an ortho image and its elevation. So open. So this comes in as an image, but again, it's something that you can use to help you build what you need to build. So in this case, I brought in both of them, but we only need the one. So what we're going to do is we're going to try and make this fit to our window. Okay, so at this point then we will also want to load in our other ones, but we'll adjust this one first to make it work for us. So I'm going to go into the types of this window, and there's a whole bunch of in here. I don't care about any of these sizes. They just came out of a box, so I'm just going to delete a bunch. So I just have the one that I need. Okay, so all I have is W2, and what I'm going to do is I'm going to physically measure this window so I know what size I need to make it. So from here, and we'll zoom right in. This is the beauty of ortho images, is we can get pretty close. We'll come over here too. Okay, so we are roughly 3'3", and what I'll do is I'll then open up this window, and I will say that the foot 3, apply, okay. And then I'm going to take the height of the window as well. And maybe you want to take a few more measurements just so you can get better accuracy, but it's up to you. So, right, and we're 5'5" and a bit, and I'm going to take that, plunk it in there as well, apply, okay. So I have my window now that's the right size as far as the physical exterior of the window, or the extent I should say. And I'm going to try and just squeeze it in there as tight as possible. Okay, and double check the other side, so we got a nice tight fit in there of that window. So we are fairly confident that this is pretty accurate. Okay, and then I'm going to go to the left side here, and I will do the same, bring in another ortho image. And this is the section. So what you're looking for when you try and align these is just the top, so we know that the extents of the window, right? So you can start to see some ghosting. This is other elements, so this is the architectural feature above the window, and this is the actual wall. So what we're going to do is we're going to try and align this as close as possible to the exterior of this wall. Okay, so exterior of the wall comes down. Then you can see right now that this is completely in the wrong spot. It's going to be over here. Now the problem with windows and glass, specifically with scanning, is it creates a lot of noise. So I highly recommend having data from both sides on this side. It'll make your life a lot easier trying to do these things, but in this case we only have it from the one side. Okay, and it's hard to tell here because we lost some of the data, but this is the bottom sill piece, the architectural feature that comes up, so it's pretty bang on. And then we can come to the floor plan of it, and we can do the same thing. So we'll bring in that Pointsense plan. Okay, and we know it's, we're going to actually rotate this, because it came in the wrong direction. And as we bring it in, the same thing. We're going to look for the extents of the window. And again, you can see the architectural features in the background. Just shuffle this over a little bit so we're confident. And we have a pretty good framework of how to bang out this window exact. Again, like I said, if you have data from the other side, it would probably be a lot more effective. And even I've seen people go to the extents where they've put like black cardboard onto the glass so they don't get as much noise. But it just really depends on how detailed you get. For architectural purposes, it's going to be more than enough. So what you do after that is go into your window environment, you're already in your family environment, but start editing these different extrusions and stuff so that they become part of where the jam and the headers are and all that stuff. And once we're happy with the model that we have created in this family environment, we'll load it back into the project. And place it where it should go. Actually, sorry, we won't do that. Get rid of that. And what we'll do is we'll just swap this one window out that was remaining. So we're going to go down to our W2 type window and plug that in there. And then we'll have to come in and just do a quick adjustment again. So we have a pretty tight fit of that window. Turn the point cloud off here. and I'll show you what we've got so far. So you can see this is the original window. It's close, but not perfect. And then this one comes in, and it's a lot more perfect. And so you can start adding in these architectural features as well. So if I went back and wanted to get this to say we wanted to bring in this piece at the bottom, so we can just create an extrusion really quickly. I mean, obviously you probably want to set up some planes so it's parametric, but just for demonstration purposes, take that. Okay, load it back into the family. And there we have the piece that was underneath it already built into the model. So we could swap this one out now as well. It's a W2, and we would turn the point cloud back on. And we would go and align that window as well. And we'd work our way around the building. And we can use this concept for each one of these, for all the different glass that's in the front, with the curtain walls, with the doors, any of this stuff. All the concepts work the same. And you start building your windows one by one and building out your architectural features, and away you go. Alright, and now here's the final model. So we went through and modeled, the storefront and all the windows and the walls and all the architectural features that we needed to do. So this whole project took about 3 days of scanning and processing, and another 3 days of data extraction and modeling. So I think our total cost on this was around $8,000 to $9,000 to get to this stage of a level of 300. So if we just turn this point cloud off, we can take a look at the actual model. And so here's the actual model that we've done, and obviously all exterior shell as well. So if we wanted to do the interior, we would need to obviously scan it, but I think all in all it turned out really well. Alright, well, thanks for taking the time to watch this, and if you have any questions, please feel free to reach out to Cancel. Thank you very much.